Let's see what happens. Even though CO2 is solid, it's solid dry ice, it's CO2. When it dissolves in water, it produces an acid called carbonic acid. So you can see the color change here, right? We have an acid, and it's going through different colors. Green is neutral, pH 7, it goes to yellow. Now this is acidic. So the CO2 is dissolving and producing the acid, carbonic acid. So we have this nice yellow color here. So you should see this. Let it go. Why is the foam coming up? Does anybody know? Why is this nice foam coming up?
Because it's changing the state.
It's changing the state, right? The CO2 is a solid. But then you change it to what? A gas. So we see this nice gas bubbling up. This is CO2 in your soda. So that's what you see when you open the soda bottle. You want to turn it back? What do we do if you want to turn it back? We put in the base. Let's see what happens. See if we can change the color. Get in there. Get in there. Think I have to use the whole bottle? Maybe. Why is it taking a while for the color to change?
Because there's still more carbon.
We still have some, CO2 that's not dissolved. I'm going to pour the whole bottle here, guys. We want our blue back. Blue. Blue. Okay, we're going to get it. We're going to get it. We're getting the blue. Maybe we need something more concentrated here. Let's see. Needed something a little more concentrated. Yes, thank you. So there you go, rainbow based on pH.
Let me ask you a question. All the CO2 has gone out into the air. What color is the CO2? You're breathing it in and out right now. What color is CO2? It's colorless. Why is it white there? I should tell you, there is a quiz at the end of this this demonstration. Okay, it's a 10-point, it's only a 10-point quiz, but you need 9 points to get out of the room. Otherwise, you have to stay after school. Okay, until you learn. And the first question will be why is the CO2 white? I'd get to work on that one right away.
Hey, ladies and gentlemen, did you like the dry ice? Yeah. Dry ice exists or sublimes at negative 78 degrees Celsius, and that's pretty darn cold. We're about to go from cold to outright Arctic. In this class, we have liquid nitrogen. Now, 78% of what you're breathing in right now in the air is nitrogen. Your body doesn't use it, you just exhale it right back out. But if you cool nitrogen gas down to negative 196 Celsius, that's 77 Kelvin, which is about as close to absolute zero as I ever want to come near, nitrogen will condense into a liquid. So first thing I'd like to do is take the nitrogen, the liquid nitrogen, and pour it into a clear beaker so you can see what it looks like. So ladies and gentlemen, this is liquid nitrogen. Now what is that liquid nitrogen doing? It's more than evaporating, it is, I heard it, somebody said it, boiling. Yeah, we are well above the boiling point here. This boils at negative 196 Celsius, and it's probably 20-25 Celsius in this room. So it is really, really hot in this room compared to the liquid nitrogen, and so it is boiling liquid to gas. So the nice thing about liquid nitrogen is that you can do all sorts of neat little demonstrations that you can't normally do at room temperature. And what we like to do is just kind of throw stuff in the liquid nitrogen to see what happens. So, ooh, look what we have here. Yes. All right, so let's take a look at a flower. Let's go with this one. Okay. Flowers have certain physical properties. Name a physical property of this flower. It's yellow. We got color. soft and has a smell or an odor, okay? So the question is, how will placing the flour in liquid nitrogen affect those physical properties? Will they change? Will some stay the same? Let's find out. Okay, so it takes only a few seconds for us to chill out. Get it? Chill out. All right. Okay, I think that's good. So we see our flour. It's still yellow. I don't know if it has an odor, but it's no longer soft. Who are you? So, I got a whole lot of liquid nitrogen here, folks, so I'm going to pour it into this vessel here, and we can experiment with throwing different things in there and see what happens to their physical properties. Liquid nitrogen. It's hard to see. Yep. Alright, so. For you. Yes, I brought my salad with me. What do you think is going to happen to the leaf?
It's going to be like a flower.
I'm not good around plants. All right, so we have a few other things in here. So, ladies and gentlemen, we have a handball in here. Do you remember what color the handball was? Oh, okay, they remember. Do you remember what shape it was? Can you name one other physical property? Did somebody say it had a smell? It bounced. So the question is, will it still be blue? Yes. Will it still be round? Yes. Will it still bounce? No. Let's find out. Okay, it's still blue, it's still round. Doesn't bounce so well. Oh, but wait, there's more. The banana. Is it still a banana? Yes. Chemical change or physical change? Physical. Definitely physical. Okay, you guys freeze food all the time. You have this thing in your home called a freezer. Okay? But this banana is frozen so hard that we can use it as a hammer to hammer a nail into a piece of wood. Ladies and gentlemen, it's hammer time. I have one more demonstration for you with the liquid nitrogen. And it has to do with something that many of you have already learned, some of you will learn in chemistry class. You may have heard of Charles' law. Alright, so ladies and gentlemen, I have some air inside of a balloon. I am going to decrease the temperature of the air inside that balloon by pouring liquid nitrogen over it. What do you predict will happen to? Let's find out. Okay. I'm melting. It's not melting. Oh no, and she goes. So ladies and gentlemen, in a moment I will take this out of the liquid nitrogen and place it on the desk so it'll warm back up to room temperature. That will increase the temperature of the air inside the balloon. What's going to happen to the volume? It's alive. Warming. Is it still a balloon? Yes. Does it do all the things that balloons do? Yes. Whatever that is. Toss it around. Still a balloon. Ladies and gentlemen,